Hey guys, Mrs. Vaughn here. So after going over the practice problems and the Feedback Friday form, I saw that some of you guys, it seems, still have some questions about how to use Hess's law in terms of the summation equation. So I'm going to talk about that really quickly with you guys. So the summation equation is the way of using Hess's law where you take your sum of your products minus the sum of your reactants to find out this overall heat of formation in your reaction. So an example of the question is here. We're trying to determine the heat of the reaction using values in table R11, which is provided in your notes. So we have our balanced equation here already. What we need to do is we need to make sure that we look up the table values correctly. So what that means, we're going to make sure that these states match. If we don't use the right state, especially with water, that's one that they're going to use really commonly to try and throw you off because liquid and gas will appear in all tables. So you want to make sure that that letter matches. The other problem that I think that you guys ran into is that you forgot that these were molar enthalpies. So R11 gives you kilojoules per mole. If we're looking at our balanced equation, remember these coefficients that are out in front of your chemicals tell you how many moles participate in your reaction. So you have to make sure you take the coefficient times the number in your table. But otherwise, that's all you're going to do. So you're going to take your sum of your products and your sum of your reactants. Now, sum means addition. That's what we're going to be doing. So we take 4 times our number for our nitrogen dioxide that we got from our table. We're going to add to that 6 times, because we want these numbers to match, the number for our liquid water. And then we're going to subtract our reactants. We have 4 times our ammonia value plus 7 times 0. Well, why in the world is oxygen 0? Remember, elements in their standard state have a heat of formation of 0. That's because it requires 0 energy for it to exist naturally. So then you're just going to do the math. And your final answer is negative 1,398.4 kilojoules per mole. Now, the reason we have this number of sig figs is because we are using the number with the fewest number of decimal places. Both of these have 1 decimal place to their value, so that means we have to have 1 decimal place to our answer. I hope this clarifies any questions that you guys had remaining about the practice problems. If it didn't, please feel free to reach out and I will do what I can to assist. Thank you.